Hello and welcome to Talking Steam, a podcast series by Spirax Sarco. We are the world's leaders in steam technology, offering the industry's most extensive range of products and services across a variety of industries. We create solutions that set the benchmark for steam-using organizations worldwide, working with you to improve productivity, save energy, and reduce waste.
In this episode, I'm joined by industry expert Ray McEwen, where we will be discussing the plumes of steam that can be seen on most food and drink manufacturing sites. And when we talk about those plumes of steam, we're not referring to the emissions that you can see coming out of a chimney that's burning fossil fuels. We are talking about the plumes of steam that you can see coming from maybe the boiler house, from outbuildings, associated with maybe a particular process. And, we're talking about definitively plumes of steam. We're not talking about the maybe condensing gases that you can see or the condensing water that you can see on a colder day. These are plumes of steam that are present year in, year out, and all year round, regardless of the season. And in this episode, we're going to be digging deeper into why the plumes exist and what can be done about them. You'll be excited to know that there are significant energy and water savings that can be made if you capture these plumes correctly and effectively recycle the heat and water that they contain. And my guest, Ray McEwen, is based out of Cork in Ireland, and he is the Divisional Energy Engineer for Spirax Sarco in the Europe, Middle East and Africa region. Ray started his career as an engineer in the Navy before working in construction on large-scale pharmaceutical projects. He then joined the Spirax Sarco group, working as a field service engineer before taking on the position he holds now. Ray works extensively in the food and beverage sector, working with manufacturers to identify and to implement sustainability projects, particularly in the steam and thermal elements of their plant. Ray holds a master's in renewable energy management, and indeed he sets a very high benchmark as not only our first guest of this series, but of this entire podcast. My name is Mike Skidmore, and I am your host for this, the Talking Steam podcast from Spirax Sarco, where in this series we are focusing on heat recovery opportunities at food and drink manufacturing sites. And just a very quick note to say that due to the 2020 COVID pandemic, this interview was held virtually rather than face-to-face. Hello, Ray. Welcome to the podcast. Thank you ever so much for joining us. It's a long time no see. How have you been keeping during COVID?
Yeah, Mike, how are you going? It's good to catch up with you. Like everyone else, I've been busy. The way I conduct my work has changed. A lot more remote work from the customer, but a lot more engagement with the customer. So a different alternative way of supporting our customers over these challenging times. So all good, thank you.
Fantastic, that's really good to hear. So Ray, the intention for this podcast and really our conversation, we are looking here at heat recovery opportunities within the food and beverage industry with a particular focus on those plumes of steam that we see coming from food and beverage manufacturing plants. So Ray, I'm really hoping to kick off this conversation if we can go in to start exploring what some of those visible plumes may be when it comes to the steam system, and something that our listeners here can begin to relate to. So from your experience, Ray, and from the sites that you've visited and from the customers that you've worked with, what are the main reasons why those visible plumes exist on a customer's site?
Okay, Mike, that's a very good and interesting question, and it's something we come across quite frequently. I suppose for the customer's perspective, they need to understand or differentiate between the two types of steam losses, which you see arising from a condensate recovery unit or a production facility. There's the unavoidable losses, which are basically the steam losses which are resulting due to the process operation, temperatures, pressures, etc. And there's the controllable losses, which are the hidden losses normally associated with, say, failed open steam traps and distribution systems. So if we're looking to try and optimize a system, we need to determine, one, whether the steam loss we see is as a resultant of a process, or if the steam loss is because of, say, poor trap maintenance on site. So it's important as a good starter to really kind of understand the process, your systems, and from then that knowing that whether it's energy which is lost, which is recoverable, or energy which could be managed through improved maintenance, for example.
Okay, so that's really interesting to understand. So you talked there about controllable losses, and in that context, you've spoken about steam traps and you've spoken about safety valves on the system. So when it comes to heat recovery, what sort of approach should a manufacturer have to the controllable losses?
Okay, it's also worth mentioning about to see the controllable losses. So when we talk about the different types of flash steam, and to understand the amount or the availability of this energy, you need to understand the process that can potentially create this steam. What we're talking about is flash steam. And when you consider steam and thermodynamics of steam, water has an ability to retain energy based on its pressure, i.e., when you look at the steam tables, water has ability to remain in a water state at higher pressures at higher temperatures. However, when you take high temperature condensate or high temperature water and you return it to, say, a lower pressure or atmospheric vessel, like your common condensate recovery unit, then by the laws of thermodynamics, water can't retain or hold on to the same amount of energy and has to release this energy. How it does it? It does it through evaporation or flashing. So when we talk about this recoverable energy, it's this flash energy loss from condensate systems where we have temperatures or pressures above that which can be sustained under atmospheric conditions.
So you're saying that you have some of those plumes that you see are from what you call the controllable losses, which are addressable through maintenance. So that could be a leaking valve or a leaking steam trap. Whereas actually, when it comes to heat recovery, what we should be considering are the plumes that occur due to flash steam, like you've just explained, and are never going to go away, but there is an opportunity there to do something about them and begin to capture and maybe even recycle some
Correct.
elements of them.
And again, that's a good summary is that the losses from the likes of the traps and the safety valves, they can be controlled and addressed through improved maintenance, better trap maintenance regimes. But again, just for for everyone's understanding, the process-related flash losses are unavoidable. There is no type of say steam trap which can control this, and it's an inherent function of the process itself and the temperature and the pressure of those discrete processes. Hence that we call this recoverable energy, in the sense of that we can't control the occurrence of it, but we can control how you can recover the energy and basically absorb the energy and transferring it to alternative utilities or even back into the process itself.
Thank you, Ray. Thanks for the clarity on that one. When we think about flash steam, and in particular, when we think about the food and beverage industry, how many sites, as maybe a proportion of the industry, would you say this is applicable to?
I suppose the best answer, it's an industry-wide problem. And again, just to reiterate that the occurrence of this flash steam is determined on the temperature and the pressure of the end user. So where you have condensates greater than 100 degrees, you're going to create flash steam. So when you consider a lot of our industries, where you have, again, like retorts, jacketed vessels, and where you have sterilization temperatures close to above 100 degrees, then the occurrence of flash steam is unavoidable. However, what we need to understand is that this flash steam has energy content. Also, it is water lost. And what is important to consider that when you consider the mass of the water that's returned, say 100% of water, and if that 100% is 1,000 liters, on average, you would lose about 10% of the mass of that or 100 kgs as steam which is exhausted to atmosphere. However, what's more important to recognize is that when you consider the latent heat which is required to convert water into steam, up to about 50% of the condensate energy is lost through this flash steam. So you have quite a high energy content and a high percentage of the energy or residual energy of condensates being lost through this flashing occurrence. When we're talking about energy recovery or energy optimization, it's important to understand these key principles.
Okay, and that reminds me of a project I was working on a couple of years ago at a manufacturer's site where this manufacturer had a large tank of water, which was a key ingredient for their process. And that tank of water was, it was a large stored volume of water. It was taking about 30 minutes to heat up, using steam to do that. And then it was immediately drained and then refilled again and heated again from a kind of cold temperature. That manufacturer was using steam directly onto a coil that was within that tank and heating it at 8 bar gauge steam. And that was for about 28 minutes of heating. So what that actually led to was where that 8 bar gauge of steam was going into a coil, it was giving off its energy, condensing into a liquid and into the water that was also then existing at 8 bar. That water at 8 bar, or that condensate at 8 bar that remained in the coil and then passed through the steam trap, was going from 8 bar at about 175 degrees C. And on the other side of the steam trap, it was going into atmospheric pipework, which meant that it was at 0 bar gauge. And we all know that 0 bar gauge means that water can only exist at a maximum temperature of 100 degrees C. And it meant that that extra 75 degrees C in temperature was an excess of energy, which caused that water to almost reboil. And what that then meant was where that atmospheric pipework and that steam that was generated from the water reboiling with the excess energy, it looked for the path of least resistance, which ended up being a vent coming off the condensate receiving unit, which we quite commonly see either tucked away in the corner of a boiler house or tucked away in the corner of a plant room somewhere, which then has a vent going out of the roof or out of the wall. And this manufacturer, for that 28 minutes each cycle, when that 8 bar gauge steam was being put onto this tank of water, there was a significant amount of flash steam coming out. And actually, look, when we look at the numbers, from 8 bar down to atmospheric pressure, that was about 14% of that steam that was being used. So 14% of the steam that is being applied to a process, especially if that process is using, 500 kilos an hour or 1,000 kilograms an hour, that's a significant amount of energy, and not only energy going up that exhaust, but water as well. So Ray, are there any particular applications within the food and beverage industry where you have seen, from your experience, significant losses happening in a
Yes,
similar case to that?
there's multiple cases and multiple examples, and a lot of our customers, are all experiencing the same conditions. And what we try to do is to try and look at the process, understand the process, because in your case you mentioned, which is something which is quite similar in a lot of industries. It could be a batch orientated process. So like you mentioned, 30 minutes of high water demand, 30 minutes of no water demand. And a lot of industries work to similar kind of recipes or process conditions, batch orientated or high demand, low demand. And what we look and see is that this occurrence of flash steam could either be continuous or, like in your scenario, on off pending the process. And this is where there's a level of understanding or appreciation between what we call the synergy of the availability of this flash steam and the synergy of how you consume this flash steam or how best to make better use of it.
We all know that steam is generated from water. So by recovering steam, there should also be, or recovering flash steam, there should also be the opportunity to recover water. So how would that typically be done? Or how would that manifest itself?
So it's about engineering a solution using the correct technology and the technology which was specifically designed for this application, like the exhaust vapor condenser. You can use standard heat exchangers, but provision must be made for condensate removal as well, because it's important to understand that this is zero pressure steam, which means zero pressure condensate. And unless you provide for gravitational condensate removal or other means of pumped condensate, then the system won't work effectively.
Well, Ray, thank you ever so much for a fascinating insight there into your experiences and helping give more clarity and understanding to what those visible plumes are from a typical food or beverage manufacturing plant, and certainly what a lot of manufacturers may see as something that means the steam system is working and is unavoidable, but also that it is possible to do something about it, whether it's through taking simple maintenance action or looking a little bit further into understanding where it's coming from and then putting a solution in place to help recover either that energy, that water, or both at the same time. And Ray, before we get to the end and before we wrap up, do you have any final piece of advice that you can give our listeners who do recognise those plumes of steam around their plant, but are unsure as to what to do next?
Okay, I suppose that, again, just for the listener's perspective, is that you're no one different to any of your competitors or industry in general. This is a common wide problem. And again, where it's a process related, it's unavoidable. So once you operate above 100 degrees, you're going to have this currents of this flash steam. Again, I suppose the first point or addressable point is to undertake steam trap survey and trying to eliminate as much of this controlled losses as possible. So I mean, controlled losses is that failed open traps where through trap maintenance you can replace the trap and eliminate the source of the problem. When it comes to the unavoidable losses, which are the process related losses, again, look at your process, look how often it operates, you look how much steam that it's generating, and look within not just the process itself, but adjacent utilities to see, how much energy do I have and how much energy am I using by adjacent utilities, and do they form a natural match in the sense that I can use this energy from my process A and recover it, for example, into process B. So I think that's the most simplistic way to this, is that apply logic, be as simplistic as possible, stand back and look at the process, understand the process, understand the frequency, the duration, and again, to understand which utility could you best integrate or sync this energy into. Okay.
Ray, that's brilliant. Thank you. And I think if we were to really summarize that down into almost one statement, it's understand where it's coming from and where it could go to.
Exactly. Simplify it.
Wonderful. Wonderful. We like simple. Ray, thank you ever so much for joining us on this episode. It's been an absolute pleasure to have you on board. And hopefully we'll get to speak to you again in a future episode on a different topic. So thank you.
Thank you, Mike. It's been my pleasure.
Thanks there to Ray McEwen for his insightful view into the plumes that we see around a steam-using manufacturing plant, but we don't often know what to do with next. In next week's episode, I'll be joined by an industry expert from the USA, where we will be looking into and discussing the benefits that can be realised by food and beverage manufacturers when reducing those visible plumes and capturing flash steam. These vary from the immediate fiscal and utility savings to the less obvious benefits that contribute to a better working environment. All that's left to say is thank you for listening, and I hope you continue to join us on this series of Talking Steam.
Thanks for listening. We hope that you enjoyed this podcast and join us again soon. If you have any questions about the content covered in this podcast, please reach out to us or your local Spirax Sarco engineer. Watch out for future episodes coming online soon. Follow Spirax Sarco on LinkedIn and listen to get updates on new episodes.